Okay, so the camera died when I was giving this, so here's the second take. So we need to talk about rational functions. And the goal here is going to be to develop a way to graph, rational functions. The goal here is going to be to develop a way to graph rational functions. So a rational function, remember, is a p of x over q of x, where p and q are what?
Both continuous?
No.
No,
That's not quite
polynomials.
enough. Polynomials.
Cool.
Okay. So p and q are polys. Okay. So examples of things like this. We'll probably use this one in a bit. So like f of x is x plus 1 over x minus 2. Or more things.
Right.
So just immediately, right off the bat, what can I tell about this thing?
No 2. X can't be 2.
Okay, so first things first, we need to talk about vertical asymptotes and holes. These have to kind of go in the same place in my head. So a vertical asymptote happens when the bottom is 0 and the top isn't. So this guy, for instance, has a vertical asymptote at 2. That's as opposed to something with a hole, which would be something like maybe g of x is x minus 2 over x minus 2.
Really want to count that as a 1.
Yeah, you really want to look at this and think about this as a onesie, right?
Yeah.
You really want to go, oh, well, this crap, right, is really 1.
Mm-hmm.
Well, remember there's that little asterisk on that equal
Except
sign.
when x is 2.
Because this really is only 1 when x isn't 2. When x is 2, it's not. So the graph of that function looks like y equals 1, except at, oops, not there. Where's that hole? It's at
Right
2. And it's just a little hole punched in that thing.
Mm-hmm.
And what do I do with 2? Well, I don't freaking know. It doesn't seem to go anywhere.
We can just take the limit to it, right? Kind of plug it.
Yeah, so we could think about plugging that hole, which is exactly what that canceling is doing. So holes in general, right? These look like the bottom is 0 and the top is 0. Okay, now back to vertical asymptotes, small caveat. You can stick a hole on top of a vertical asymptote. So what I mean by that is maybe this is an example function. I'm going to call this one, oh, what the hell? It's inspired by f of x, right? So I'm calling it f hat. And it's going to be f, okay, so x plus 1 over x minus 2. But then I'm going to multiply top and bottom by x minus 2. Right?
Mm-hmm.
So now this guy has a hole at 2, right?
Mm-hmm.
But it also has a vertical asymptote at 2, so which one takes precedence?
The asymptote? Does it matter, honestly?
Yeah, it matters, and the asymptote definitely takes precedent. Because this thing, right,
Mm-hmm.
I would normally say, well, equals with an asterisk, and then reduce it. So it's x plus 1 over x minus 2.
Right.
But here I don't even need the asterisk, because 2 isn't allowed in this thing anyway. So I don't even have to modify. These are literally the exact same function.
So does the hole allow us to do something different, though? Like putting the hole there, can we do something with that cool that fixes something?
No. So this is a totally useless thing, except that I have to add this little note to vertical asymptotes, which is when the bottom's 0 and the top's not, or when the bottom is more 0 than the top.
Cool.
So you might have to reduce a little bit before you get to this case. If you reduce fully, then you can think about a vertical asymptotes when the top's not 0 and the bottom is.
Right. Okay.
Okay. So this is also separated from the third thing I need to talk about, which is zeros. So a 0 is the other thing. basically my three cases here. Vertical asymptotes are like number over zero things. Holes are 0 over 0 things. And zeros are,
Number, 0 over number.
yeah, perfect. So zeros happen when there's like 0 over a number. So this is when the top is 0. What the hell? Let's write top equals 0 and bottom is not. And why don't I need to worry about making a statement like, or the top is more 0 than the bottom?
Because we got that covered over there.
Yeah, because that's covered up in holes,
Yeah.
right?
Yeah.
Okay, so an example of a 0, actually if I go back to F, where does F have a 0?
2. Wait,
No.
no, -1.
Yeah, so it's got a vertical asymptote at -2
Mhm.
and a 0 at 1.
Mhm.
So if I wanted to try to draw a picture of F, right, I can do at least a couple things right now. So this is what I know about f of x so far. I know that at -1, I've got a 0. And at +2, there's a vertical asymptote. So far this is what I know.
Okay.
Now I could ask other questions here, like,
when x is 0, we could find an intercept there.
yep, so we could graph another point by plugging in x is 0. We could graph a bunch more points.
Mhm.
Let me dump some of this stuff and we'll get a better method for graphing everything.